in calculus, when you do trigonometry, you're going to be doing trigonometry around a unit circle. So we normally think of trigonometry as right triangle, like right triangle trig, and using right triangles and the ratios of sides. Well, unit circle trigonometry actually yields the same trigonometric values, but now what we're going to be doing is we're going to be rotating around a unit circle. And so you're going to be able to use trigonometry to represent, like the orbit of planets and this sort of periodic behavior when you rotate around, and then it starts over again and again, and it repeats itself. And these form like these waves. The graph of sine and cosine are these trigonometric waves. And so this really opens up trigonometry to a lot of other things that you wouldn't be able to do with just right triangles. Okay, so we're going to start by talking about the angles around a unit circle. Okay, so let me first do degrees, just because that's probably what you're familiar with, especially if you haven't done unit circle trigonometry before. But it's going to be important for you to learn things in terms of radians, and it's actually, I think, a lot easier in terms of radians once you get used to it. But when you do calculus, you have to do things in terms of radians, because that's what makes the derivative and integral formulas work out so nicely. It wouldn't work out the same way if you did it in terms of degrees. Okay, so basically here, so in degrees, this is like a unit circle, let's say. And so this point here would be 1, 0. This point up here would be 0, 1. Right? This point down over here is negative 1, 0. And this point down here is 0, negative 1. Now, when we measure degrees around a unit circle, we're going to start with this radius, and we're going to allow it to spin around the circle counterclockwise. Okay, so not clockwise. This is kind of like the arm of a clock spinning around, but in trigonometry it's going counterclockwise, and it's starting here. So this is like 0 degrees, and if you got up here, this would be 90 degrees, right? A right angle. And then by the time this thing rotated over to this side, this would be 180 degrees. Right? If you rotated down here, this would be 270 degrees. And then you rotate from here to here, this would be 300. That's 306. I'm going to do down here 360 degrees, right? And so if you go all the way around the circle, that's 360 degrees. Now the thing is, you can keep going, right? So 360, and if you go back up to 90, that would be 450 degrees, it looks like. And then another 90 would be 530 degrees, and you could keep going. And basically, you could go however much you wanted to go, okay? And if you go clockwise around the circle, then they would say that that angle is negative. So if you're like here, and you go down here, then this would be like negative 90 degrees. This would be negative 180, negative 270, negative 360, so on. Okay, so this direction is positive, this direction is negative. Okay, and so you could also add some other angles. There's like 30 degrees, right? There's 45 degrees, and that splits this quadrant in half. And then there's up here 60 degrees. And these are very common. So a 30 degree, 45, 60. This would be 90. And basically you could have these all around. So this would be 135 degrees. This would be like 260 degrees. So this would be 120 degrees. And then this one is kind of like this 30 degree angle, but it's up here, so this is 150 degrees. Okay, And you could, and I didn't do super good there, but you could put them down here, so like this, and then these could go down here, and you could find all those angles too, okay? And now I could like go spin around and stop at 60, or I could go all the way around the circle here and stop at 320. I'm sorry, not 420. So like 60 degrees and 420 degrees are coterminal angles. And so what we're going to find out is the trig values for 60 degrees and the trig values for 420 degrees. The trig values will be the same. And so the trig values depend on where you stop on the unit circle. Okay? So you can spin around as many times, but wherever you stop, at that point, it's going to be the same as if you just spun around directly to that point. Okay? Also, well, I'll just stop there. Okay? So you got these coterminal angles. Let's now talk about radians. And so this is going to be very, very important. Okay, and I'm going to make this a little bit bigger. That's not too bad. So this point, these are the 4 points here. So this is 1, 0. This is 0, 1, negative 1, 0, and 0, negative 1. Okay, so the idea of the radians here is if this is a unit circle, this is the radius of the circle, right? This distance. And that radius is 1. Okay? Now if I took that, and I wish I had a string or something that size. So if I took a string, I could lay it along this length here. So I could take this and lay this so that I would have like about 1 radian, or 1 radius around this circle. And that would like form an angle, right? And this would be 1 radian. Okay. And so, but this is so the arc length here is 1, and when you have an arc length of 1 around the unit circle, the angle that forms is 1 radian, and that ends up being about 57 degrees. Let me give you maybe a few more decimal places. So pi divided by 180 divided by pi, and that's like it's approximately 57.3 degrees if I round to 1 decimal place. So 1 radian is almost 60 degrees, but not quite 60 degrees. Okay? So now the question is, how many radians are around the circle? So if you take the circumference of a circle, this is equal to 2 pi r. And so 2 pi times the radius of a circle gives you the circumference. So if our radius is 1, it'd be 2 pi times 1, and that would just equal 2 pi. Okay, and 2 pi is approximately 2 pi. That's approximately like 6 point, I'll round to 2 decimal places, 6.28. Okay, and if I round all of these to 2 decimal places, this is really 57.30 degrees. It would have rounded up. But it would have been a 0 there. So if you go all the way around the circle, the actual length of the distance as you measure around the circle is 6.28 units. Okay? But we're going to use 2 pi. So this is this is like an angle of 0, but if you measure all the way around, then when you get to here, that's like 2 pi. And we're going to say, when you go around the circle once, that's 2 pi radians. Okay? And so, once around the circle is 2 pi radians. If you go twice around the circle, that's 4 pi radians. This would be 6 pi radians, so on. If I go backwards around the circle, that would be negative 2 pi radians, negative 4 pi radians, and so on. Okay? So if you, all the way around the circle is 2 pi radians, and halfway around the circle is just pi radians. Okay? And so 180 degrees is pi radians. Okay? And so a 90-degree angle would be half of pi. So this would be pi over 2 radians. Okay? And so down here, this angle is actually 3 pi over 2 radians. So how do I get this? Here's the way to think about this. This is what helped me finally get this. Is I'm just counting pi over 2. So this is 1 pi over 2. And this is 2 pi's over 2, which simplifies to just pi. The 2's would cancel out. And this is 3 pi's over 2. So I got 1, 2, 3 pi's over 2. So you could think of it like this. 3 pi's over 2. So once around the circle is 3 pi's over 2. But put 3 over 1 and multiply numerator denominator, you get 3 pi over 2. Okay? So that's how these work. So 1, 2, 3 pi's over 2. So now, let me just show you that. So, and this, boy, that is really hard to look at. So let's just put 2 pi here. So we'll say 0. We'll say we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. What I want to do is I want to show you that these quadrants here, so pi over 2 is just like 6.28. So pi, of course, is approximately 3.14. Pi over 2 would be, let's figure it out, pi over 2 is approximately 1.57. And then multiply that by 3. So 3 pi over 2 is approximately 4.71. So you can think of these as, 0, pi over 2, pi, 3 pi over 2, 2 pi. This would be, I would have 5 pi over 2, right? Because I'd have 1, 2, 3, 4, 5 pi's over 2. And then 6 pi's over 2 would reduce down to 3 pi. So like 1 pi, 2 pi, 3 pi. Okay, and then down here, so this was 6 pi's over 2. This would be 7 pi over 2. So if you go all the way around the circle and then go back down over here, that would make this 7 pi over 2, and so on. Okay, but these quadrant angles, you can also think of them as numbers. So 0, 1.57, 3.14, 4.71, 6.28. And those numbers are actually giving you the number of units of the arc as you go around. So you have 0, and by the time you get up to here, you're 1.57 units, and then you travel down the arc here, and then you've traveled 3.14 units, and then 4.71 units, and then 6.28 units. And then you could go up again. If I added 1.57 to 6.28, that'd be how many units I'd be there. So usually when you go around the circle and just stop at random, it's a real number. And the real number, like if I go around and I stop here, the real number is going to be somewhere between 1.57 and 3.14. Okay, or if I go around and stop here, it'll be somewhere between 4.71 and 6.28. Okay, it'll be a real number, and that real number will be the length that you've traveled around the circle. Okay, but it's nice as you're learning trigonometry to learn a handful of these special angles that have pi in them, and so oftentimes textbook problems are going to involve some special angles. Okay, and so just to make it a little bit clean here, let me show you what these special angles are. And by the way, these special angles are going to be the ones that correspond to 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120, 135, so on, around the circle. But they're going to be in terms of pi. Okay? So, do a nice big one, huh? Not perfect, but it'll do. Actually, I could do maybe a little bit better. A little bit better. Okay. So we got these points. Right? Okay. So we know this is 0 pi over 2 pi, 3 pi over 2, and then 2 pi. And then you could keep going around. Okay, so first you have like these 45-degree angles, right? So we're going to put these. We're going to put these in there. So if I do half of pi over 2, well, that would be pi over 4, right? So the 45-degree angle is like pi over 4. But I want you to start thinking of these just as like pieces around this unit circle. Like this is, if this is pi, this is half of pi, this is a fourth of pi, right? And if you look at this one, what is this angle? Well, this is pi over 4, 2 pi over 4, 3 pi's over 4, right? 4 pi over 4, this would be 5 pi over 4. 6 pi's over 4, reducing down to 3 pi over 2, 7 pi's over 4. Okay, and these are the radians for all those quote-unquote 45-degree angles. Okay, let me show you something. So one way of thinking about this, like if you wanted to know this one, the way I think about it is I remember for pi over 4, there's going to be 8 of them around the circle, right? There's going to be 4 of them for the top half of the circle, 4 of them for the bottom half of the circle. So if I know there's 8 of them, then to get this one, I just have to go back 1. So if there's 8 of them, then this must be 7 pi over 4, right? Or another way of thinking about this is if I go halfway around the circle, I know there's 4 pi's over 4. So what's this one going to be? Well, it's going to be 1 more than 4, 5 pi's over 4. Or what's this one going to be? I back up, 3 pi's over 4. That sort of idea. That's what helps me memorize these. So I don't just have them memorized by rote, where I have to go not understand and go back in my mind and pull them out of my memory. I kind of am counting the number of pi's over 4 around the circle. Or I'm knowing that there's 4 of them backing up 1. Or I know that there's 4 of them moving forward 1. Okay? So, now this is going to be like the 30 degree angle. I did not do very good there. But the 30 degree angle is that's actually 1/6 of pi. Okay? And so this is pi over 6. Right? And then if I go another, you know what? Here's what I want to do here. Those are the pi's over 4, right? So now let me do another one with just the pi's over 6. Or let me do one with the pi's over 3. Okay? So a pi over 3 is where I take the 100, here's pi, I take that 180 degrees and divide this into thirds, right? And if I divide 180 into thirds, I get 60 degrees. So this pi over 3 is like a 60-degree angle, okay? And then if I go another 60 degrees, I get 120 degrees, and that's going to be 2 pi's over 3. So I got 1 pi over 3, 2 pi's over 3. 3 pi's over 3 would be pi, okay? And then this one, another pi over 3. So 3 pi's over 3 plus 1 more would be 4 pi over 3. Okay, and then if I go if I go another pi over 3, this would be 5 pi over 3. And then if I go another one, I'd get 6 pi over 3. I'd have it 2 pi. Okay, so it's like there's 1, 2, 3 pi's over 3 on the top half of the circle. 1, 2, 3 pi's over 3 on the bottom half of the circle. Okay, and these are split up by the pi over 2. So this pi over 3, please, this 60 degree, there's 30. So this is like 60, 90, and then 120. Okay, so this angle kind of splits that pi over 3 piece in half, right? And this one down here as well. 3 pi over 2. Okay, so, but now what if I go 30 degrees? So 30 degrees would be like half of 60 degrees, right? 30 degrees, and half of 60, or half of pi over 3 would be pi over 6. Or I can think of, if I took 180 degrees and divided into 6, I'd get 30 degrees. So if I took pi and divided into 6, I would get pi over 6, okay? And then if I do another 30 degrees, I would have 2 pi over 6. That would reduce down to pi over 3. And then if I did another 30 degrees, that'd be 3 pi over 6, which would reduce down to pi over 2. If I did another 30 degrees, that would be 4 pi over 6. That would reduce down to 2 pi over 3. And then if I did another 30 degrees, that would be 5 pi over 6. And finally, we would get to one that doesn't reduce down, right? So there's like 1, 2, 3, 4, 5, 6. And all these should be the same length, but you can kind of see them. 1, 2, 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6 pieces. So there's 6 pi's over 6 halfway around the circle, and another 6 of them down here. So there's 12 pi's over 6 all the way around the circle. Okay, and so this one down here, now this is where it's really helpful to use the trig, right? If there's 6 pi's over 6 here, if I back up one, that's 5 pi over 6. Because I'm taking 6 pi's over 6, going back, I'm lowering it to 5 pi's over 6. So if I move it forward, that would be 7 pi over 6. And that wouldn't reduce, right? So 5 pi over 6, 7 pi over 6. And then if I go another pi over 6, this would be 8 pi over 6, which would reduce down to 4 pi over 3. And this would be 9 pi over 6, which would reduce down to 3 pi over 2. This would be 10 pi over 6, which would reduce down to 5 pi over 3. And then this would be, and boy, all my pieces are not very not very accurate there. But that's okay. You get the idea. So 5 pi over 3, and then oh yeah. So this is the 10 pi over 6, right? So if I go one more, this would be 11 pi over 6, right? And these are like 7, 8, 9, 10, 11, 12. So there's 12 pi's over 6 around the circle. If I back up one, that would be 11, right? And if I go all the way around and stop here, there's 12 pi's. This would be 13 pi over 6, right? Or let's say I want to know what if I go all the way around and then I stop here. Well, there's 12, and then 6 more would give you 18. Back up one, that would be 17 pi over 6. So 17 pi over 6 would be coterminal with 5 pi over 6. Okay? So that's the idea of radians, okay? And this is really important. And I think this is easier than degrees. You're probably more familiar with degrees. Let's see here. But let me show you what I mean. Like if I had to find one of these, like this one down here in degrees, you know, I have to think like 270, and then I go 3 more, that's 300. But I have to think in terms of bigger numbers. Here, you know, I got 3 pi's over 4, and, I'm sorry, I got, so if I wanted to know this one, you know, around the circle would be 6 pi's over 3, and I back up 1, I get 5 pi over 3, right? Or if I go all the way around to here, 12 pi over 6, back up 1 would be 11 pi over 6. Or if I wanted to know this one, in terms of degrees, I'd have to think this is 180 degrees, and then I have to move forward 30 and think, oh, 210. But here, I just think there's 6 of them, and then that's 7 pi over 6. And so here the numbers are a lot smaller when you get used to using these. To me, it's a lot easier. Okay? And so that is the idea of these angles around the circle. And in calculus, we're going to do it in terms of radians. So you got to be good at radians, and I don't want you to just memorize, or I don't want you to just convert your radians back to degrees, think in terms of degrees, and go back to radians. That is not the way to do it, and it'll cause a lot of problems as the semester goes along. You got to learn to think in terms of radians. So, okay, in the next video, we're going to learn about special points around the unit circle.